Did you get mine? I did. I just wrote it. Okay. The 446 number? The 446 is for I didn't call you out. I don't know who's
Okay, so let's get our minds together and work on finalizing our group project, and we'll go over it so in fact you know what is involved. So you will note that we are looking at the rubric for your biochemistry project, which involves carbohydrates, lipids, which is fats and waxes, and proteins, which could be enzymes, vitamins, amino acids. And so we're just calling it a biochemistry project for nutrition, and actually for patients that perhaps would have diabetes as a risk factor. So group 1's group, they are working on diabetes and iron. Okay. Can you say a little bit why diabetes and iron? Have you come up with that title yet?
Not yet, but diabetes, I have it in my family.
Oh, in your family. Okay, so you want to learn more, which is great, right? And you'll notice, I think, maybe there'll be some overlap. So we'll want to try to, specialize and branch out a little bit more. We'll try just after. So determine a carbohydrate, lipid, protein function that is important in maintaining good health for patients that may have had a triple bypass, or maybe there for peripheral arterial disease. How many have heard of that? The PAD, right? Would you like to share?
I just know my father-in-law, he had the quadruple bypass and then he had like the pacemaker as well.
Okay. And Jennifer, are you familiar with peripheral arterial disease?
I just think that like the arteries harden and that's why the flow is harder.
How do you know that someone has poor circulation in the legs? You take blood pressure reading with your arm, right? So to check for peripheral arterial disease, you check on your ankle. Anyone has done that? You have? Okay. So you have the cuff and stuff. I don't know are you able to bring something like that?
I don't think so.
They don't have that.
You can? Yeah.
I don't know, but I can try.
Yeah, see, or, no, just the blood pressure monitoring device, right? Yeah. The one that was on.
Okay.
Yeah.
I can bring that.
Yes, we did that in our class, 6.5 week class at Central. It was really very popular with us. We got extra points too. Okay, so then you have to discuss a problem and a deficiency or an excess of a nutrient. So far, and then you want to explain the remedy for improving the diet. And then maybe you can give a history of the patient, right? So I think most of you will want to look at your immediate family, so you'll learn more about it. And for the content for the health condition, what would be the name of the health condition? So a couple of health conditions. One health condition I mentioned was peripheral arterial disease, right, or PAD. So peripheral arterial disease normally occurs when people tend to also have high blood pressure, right? And so when you say what would be the name of the health condition, what does this mean, how do you get it, and so try amongst yourselves, right? So you'll note that the rubric has 50 points for each one, or not 50 points, how many points did I assign? Yeah, 25 points for each for the content. So content is really very important. So you see how the distribution are on the second page? Let me go to that page. So scoring rubric, 50 points for, instead of either for the dietary element or health condition, but we'll just try to combine it, right? For the health condition and the dietary recommendation. Okay? Good, good. I'm seeing some of you nodding your heads, right? Yeah.
I don't want to skip too ahead, but where it says points for D12, are we supposed to post it on the
Put your PowerPoint on D12.
Oh, okay.
Because what I want to do, because it might not be to get some extra points, or I might want to say, how about adding this to make it, okay? Yeah, because you know when we write things, I know we edit it until the very last minute. There's still room to edit. Yeah.
Yes, I was gonna say if we are supposed to send it to you from D12 or
Yeah. Send it to on D12, but you'll have the final copy when you present. You can bring your flash drives.
oh,
Yeah. Okay. Yes. Yeah. So make sure those that don't have their goals yet, right? So turn it in for like 10 points entrance pass today. And so Chris, you had a really good question, right? You wanna on the visual, right? You had a question on the. So let's look at the first page.
Chris said she's gonna rap.
Exactly. I have.
As she told me.
When I did this, right, it was actually gifted middle school kids that came up with raps and skits. It was really very, very, very creative. So you hand out. So you should have at least 15 slides in a group, right? 15 slides. And speaking time around 15, 17 minutes. So we'll schedule like 20-minute blocks. Yeah. Per group, right.
20 minutes per group.
Yeah, per group. Are there anyone here that wants to present individually? There's always, I always have one or two that wants to do present individually. 20 minutes per group.
Well, 20 minutes.
Yeah. So 15, 17 minutes, and we'll time it, right? So try to get your presentation about 15, 17 minutes, and then one question. Okay? And you see the handout also, right? And some of you, if you want me to print the handout, see in this portion here, I'm going to make this smaller so that you can see. So each group should have a handout that is a one-page summary of their subtitle, a short abstract, right? Maybe 2 or 3 sentences, and then the content, right? And so we'll try to. If you email me those, and I can get it printed Monday, so that they'll be ready, so we don't have to keep on. Because today it took me quite a while to wait for the print things out and wait for them, waste of like 30 minutes. Okay, so here are some websites where you can look for some additional information. What was nice I saw this morning, Stanford actually has a study on cancer and nutrition. Right down there. So an interesting insight, and of course a lot of Harvard and government websites. So the topics already some of you have chosen. And then, so any questions? Any questions on that? So are we good, right? We're good? Okay, so make sure you bring this on the 29th. And then I'm still waiting for your goals also.
And that's our last class day, right?
Yeah. Okay.
Will you post the grade for the PowerPoint itself, or are we just gonna get the final grade and that's it?
I'll show you the grade after.
Okay.
Okay, so let's look at so I gave you a handout on some extra calculations on chapter 9, calculating half-life. See if I can bring that out also. So some of you expressed the need to see some more solved problems. So there are some examples on how to do some half-life questions. So if we take a look at this, right? So you have barium 122, and you see in our periodic table, where is barium? So barium is here, right? That's normally most of the metal they give you when you have a CT scan or something like so, right? It could be flavored with cherry or blueberry, there you go. So barium 122 has a half-life of 2 minutes. Why do we want to use metals that have short half-lives? So then, why do we want to use materials with short half-lives? We discussed that last week, right? So that our body can excrete it readily. Because there could be some word problems like that. So you have a fresh sample, you have 80 grams, and it takes 10 minutes to set up an experiment. So how much barium will be left when the experiment begins? So if the half-life of barium 122, T1/2 is 2 minutes. So you want to write down like a table, time maximum. Then start, you're given 80 grams. So the half-life after 2 minutes becomes 40. So then we ask, how much do you have after 10 minutes? So just keep on getting half and half and half all the way down to 2.5. So you all understand that? So that's really interesting. And then the other type of question, I think, that, and remember, you had a classmate that she works at Holy Cross, right? And she said that the most widely used radioisotope is technetium-99, megastable. Now that's Erica, right, in the 4 o'clock class. So if you have a problem that asks you, if a lab receives a shipment of 200 grams of technetium metastable 99 and only 12.5 grams remains, what is the half-life of technetium? So a suggestion here is like working backwards. So if you end up with 12.5 grams, right? So then there would be 25, and until you get the original 200 grams. So that means 200 grams would be 6 hours. So in the back, some of you, we're not quite sure how to do the log. It will not be on your exam, right? Because we already did chapter 8. But just for your understanding of how you're doing this, because when you do an NCLEX exam, sometimes you need to know how to find the pH and determine whether you have metabolic alkalosis or acidosis. So the question here would be, how would you get the log? In other words, how would you find what's the hydronium ion concentration if the pH is 8.34? In the exam, I only asked you what would be the pH what would be the hydronium ion concentration if the pH was 8, right? So then the answer would be 1 times 10 to the minus 8. But now, what would be the pH if the hydronium ion concentration is 8.3? So how many of you know how to do that already? Because I think it's that because I might make that as one of the questions in the back of the Scantron. Okay. So in the back of the Scantron, I might write down, find the H3O plus, find the hydronium ion concentration. If the pH is instead of 8.3, if the pH is 4.65. Okay, so by definition, the pH is the negative log of the H3O plus or hydronium ion concentration. And if we look at, so you can write down the concentration, hydronium ion concentration would be the log to the base 10 to the pH, which would be 8.3, right? So 10 to the minus 8.34, as you enter that, and as a check also, if it's 8.34, therefore the hydronium ion concentration should be less than 9 because it's 8.34, right? So therefore, do you know how to do it in your calculators? Because each could be, do you know how to do it, Sheldon?
No, it's I got 5.66.
Yeah, I got 5 when I did it. It rounds it off to the highest number, but you can give significant figures.
Okay, you want to show how?
I only know how to do it here.
Okay. Yes, okay.
I use the short formula.
You use the short formula.
I use that.
The inverse?
My trick is, no, actually, I just know that it has to be 14. So what I do is, that's just a little trick that's in the book there. It has to be 14, it has to add up to 14, so it's just 8.34 minus.
Did you guys get that?
So you got 5.6.
Yeah. That's very interesting. I remember I had a Miami-Dade student So I should go with that in 2005, yeah.
So,
Did you get that? No? You wanna drop it again?
well, according to Timberlake, it has to be 14, like, it has to be 10 to the negative 14, they all have to add up, basically. So right now, you got, what, 10.84 negative, right? So in order for, I believe in order for it to balance, it has to be 14. So what you do is, there's a short thing, there's like a short rough draft, so you just take away the 8.34 from the 14, and then you pretty much get the answer. It's like 5.6.
Yeah, so using the case of W of water, right?
Yeah.
So it would be, case of W would be 1 times 10 to the minus 7. 1 times 10 to the minus 7. What page is that in the book, if you have it, if you
I
remember?
don't remember.
No?
It's in like chapter 9.
So 1 times 10 to the minus 14. But then when we say the PKW, right? So it would be just 7 plus 7 is equal to 14, right? Because pH is the negative log of the H3O2. So
296.
page 296?
Yeah, it's
Yeah.
really the longer breakdown here.
Okay. Yeah, so that's good to know.
That's really smart. There's a lot of pictures that you are.
But in your calculator, you have a DI30, it doesn't?
Yeah, the calculator, it does it, but then you have to know what you're looking for, because then it puts a point there, and then you have to move
Yeah,
it.
yeah, you have the character,
Yeah, you have to
and
carry it,
then you have to subtract, so it's too long, right?
Yeah, it's a long process.
One question, so 4.57 isn't supposed to be the correct answer. It's 5.56, I'm just going off of his method.
So 10 to the minus 8.34,
It would be
So 14 minus-
5.56, but why is that showing 4.57?
8.34.
ooh, so we'll have to,
Well, we have to punch it in
yeah.
the long way.
We'll have to do the long way, yeah.
Yeah.
So I think that's why I didn't bring it up, so I'll have to check page 296.
Are we gonna be having to do significant,
I will ask you to do something like this.
but are you gonna want significant figures? That's the
Of
only thing, the
course.
calculator can do it, but it rounds to significant figures.
Yeah.
Otherwise, you use that to go
Yeah. Well, I'll always put,
I'll do D, but I'm
three
just
significant-
gonna discuss
Okay.
only one part about it, actually.
Okay, so
I'll just do D and D.
those are important. So instead of pH, you can also,
Second B.
you can be asked what would be the hydroxide. Oh wait, that's what I mean, right? If the pOH is 5.7, remember the pOH is different than the pH. So if you're given the pOH and asked for the pH, so you have 5.7 minus log, and then get the anti-log, which would be minus 5. So take a look at that, right? So I'll take 1, so that will be in the back of the scan prompt.
Okay.
Will be worth, I'll have 2 questions. One from here.
Are you gonna give it to us in advance?
Yeah, I'm gonna write it down on the board.
Today?
No, not now. Next week, yeah. Next week, Chris.
Okay.
Good question, though.
Thanks, Ray.
Okay? Okay, great. So now let's look at, see if we can review and practice, see if we can start remembering some names. This may or may not show up in the exam, but when we classify sugar as an aldose and a ketose, remember aldo, aldehyde, keto. So So this is an aldose with 6 carbons, that's 1, 2, 3, 4, 5, 6. Remember, this is in their B12, right? So if this shows up, that would be like a bonus question. And then yesterday in the lab, we tried to make D and L glyceraldehyde, right? So classify the sugar as glucose, galactose, fructose. So this type of questions will not be in the lab, in the exam, since some of you are not, taking the lab with me. But just recognize that this is a Fisher projection, and this is a Hayward projection. You know, the rings. Because what happens is when you have, say, fructose, right? Or glucose with the 6 carbons, right? We saw that in the lab when they're long, then when you put it in water, they'll tend to form a ring, right? So not just the Fisher projection, but also the Hayward projection. So the aldehyde group of an aldose sugar can be oxidized into, so aldehyde. Remember what happens with the aldehydes? The aldehydes have a C double bond O, right? And so when you say oxidized, and this is really what they want you to recall. So when you, so if you have an aldehyde, so I'm just going to make this an R. So this is an aldehyde group, right? Aldehyde. So when we oxidize it, so what does it go to? A carboxylic acid group. So this is what's important in your exam, where you should be able to recognize that this is an aldehyde, right? Aldehyde. And then it is a carboxylic. So this is chapter 10. Right? So of course you can also an alcohol can be oxidized into an aldehyde, right? So we found this out yesterday, right? So alcohol. So there are different types of reactions that alcohols, aldehydes can be oxidized into carboxylic acid. So glycogen, animal starch, so we did an experiment with starch, is a polymer of glucose, so we saw that, right? And in this polymer, the units are linked by this polymer. So, of course, glucose units, right? So the answer, glucose units are linked by 1,4 glycosidic bonds with occasional 1,6. So you notice that the 1,4 glycosidic bonds were the ones that were like so, right? The 1,4. So let's see if I can find this one. This one is referred to as a beta 1,4. Right? So that's a beta 1,4. The other one was when when it's actually down here, and then you have the group over here. It goes down, right? This is what we made yesterday. So we made the alpha 1,4, but the beta 1,4 is the one that looks like so. Okay, so hence the answer here is letter A. So when we have glucose, fructose, galactose belong to what kind of? So we know that glucose is a monosaccharide, so the answer is letter A. So table sugar, sucrose is a disaccharide of glucose and fructose. So make sure you remember that too, right? And then polysaccharides. What are examples of polysaccharides? You know the shell, the shrimp shell, it's made out of chitin, a mucopolysaccharide. So chitin is an example of a polysaccharide. So shrimp shell. It's actually a pretty good fat absorber also, where that's why there are certain cultures that eat the shrimp skin, right? Shell. I know, we do that, the Chinese, yeah. We have garlic shrimp with choy. Crunchy. Really, really good. So fructose is a monosaccharide of sugar and is classified as a, so you won't have this type of questions because it's more memory. You will note that the type of questions I will tend to ask you is more thinking questions, right? Like questions on what's the product when an aldehyde gets oxidized? You'll say carboxylic acid. So we don't ask which is an aldose or so forth. But you could be asked something like, if galactose is an aldose sugar, so aldehyde, right, aldose, obtained from a disaccharide, lactose, so most of you know lactose, right? The difference between the Fischer projection of D-glucose and D-galactose is the arrangement of the hydroxyl group, so this OH group, right? In general chemistry, we would refer to it as hydroxide because it was OH minus, right? We called it hydroxide. Here, we refer to the OH as hydroxyl, so make sure you remember. The hydroxyl group, when you see a hydroxyl group, you get an alcohol. So the functional groups. Right? So why do aqueous solutions of D-glucose contain both alpha and beta cyclic forms? Just remember when you put them, because they tend to, when they're dangling, they're open, then they close off, and then some, dangling around and open. So there's some sort of equilibrium. So the Hayward projection of glucose can be described as a, so you won't get this type of question also. This was more like a lab building molecular models from it. But you will just note that the arrangement of the OH, so if we call this so how do we call this carbon 1? So where's carbon 1 here? So 1, 2, 3, 4, 5, 6. Remember, each is there's a carbon in there, right? And each one of these is a carbon, so this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So carbon 1 up, then down, and then 3 up. So you won't get that type of question, but you could get this type of question. A carbohydrate that produces another substance is called a, this is our lab question. Everyone answered it correctly? Okay, correct. Letter C, reducing sugar, right? That's what happened to we used Benedict solution. We converted copper 2 plus into copper 1 plus. So reducing sugar. So the example there we used was glucose is reducing sugar. So common disaccharide sugars include all except the lactose, right? Sucrose is a disaccharide, lactose is a disaccharide, maltose is a disaccharide. Polysaccharide containing long and branch chains are also called amylopectin. So this is one of the definitions. So you'll probably want to write down, what was starch called? What did we call starch? It's also polysaccharide, right? Yeah. We use the amylase, good job today. So what we did yesterday, we actually had starch, right? So we used the enzyme, so that's in chapter 16, amylase, to break down starch, because the starch is made out of glucose units. Good job, Randy. And then first we did the iodine test, and then we did the Benedict's test. So polysaccharide that consists of a helical chain of a glucose molecule. So helix would be amylose, linked by alpha 1,4. So that's one of the problems, questions you had in your lab also. So just to remember in chapter 13, make sure you know the difference between a monosaccharide and an example, a disaccharide and an example, a polysaccharide and an example. And then the reactions that occur. Okay, so on to with our addition of our text. Lipids is in chapter 15, and chapter 14 is more the carboxylic and amines, but it's the functional groups are really covered in chapter 10. So chapter 14 is just a little bit more elaborate chapter 10. So lipids is very important. Thanks for that. Oh, let me check. There you go. And bring those blood pressure. I will. Awesome. Okay, of all the following, which can be hydrolyzed to form, all of the following can be hydrolyzed to form fatty acids, but guess what, right? Make sure you don't forget to read that word. I always fall into that trap. I'll bubble all this up. But it's except.
Steroids.
So actually all of them can be hydrolyzed except the steroids, right? We don't know what the steroids are yet. So we'll see what that structure is. So what's the definition of a lipid? Huh?
Fats.
Okay, so fats and waxes, right? And let's see if we can look at what is a saturated fatty acid. So what you'll probably see in the exam are not, you'll see the formulas, right? and then you can figure out which is saturated and which one is saturated. What's the definition of saturated, which we learned in chapter 10, right? Alkanes are, which is saturated? Alkanes or alkenes or alkynes?
Alkanes.
Good job. And alkenes and alkynes are unsaturated. So we should draw the formula of stearic acid and oleic acid. I think they have they have, can someone look it up? I think they have both 16 or 18 carbons. CH2. Stearic acid is the only one that is saturated, but we should take a look at it. Or I can look at our PowerPoint and do well. Whoever can find it first, the formula. Yeah, here it is. So saturated, right? All with single bonds. Monounsaturated and polyunsaturated. And so here's stearic acid. So it's a fatty acid from animal fat, and I think there were yeah, 18. so there it is. While oleic acid should look like this. And so that's why stearic acid, it can stack up, right? And that's why it's solid at room temperature, very regular pattern. However, oleic acid, because of the unsaturated parts, so unsaturated, that's why it's liquid at room temperature, because we cannot stack them up nicely, right? They're all like kings and there's no order. Whereas we can order the stearic acid. So, which is good for us, the stearic acid or the oleic acid? Oleic acid, right? Because what happens to the stearic acid? It tends to get stuck in our arteries and veins, right? And ends up becoming cholesterol, plaques.
The oleic acid is like vegetable oils.
Yeah, so olive oil is good, right? It's really good for you because it also prevents like the lubrication of our arteries, so that if there are any dents or scratches, then it smooths it out, right? Like WD-40 for any, like the chair needed some WD-40. Okay, so let's go back to the clicker power question. All right, so they're stearic, right? So imagine so for stearic acid, they both have 18 carbons, but then on the 12th carbon for the oleic acid, there's a double bond. But for stearic, they're all single bonds. So when it's just single bonds is saturated, so very, very important.
Oh, that's the,
Yeah.
my right hand there, lipid here.
Right? Right? Yeah, okay, so now the next one. What is a triacylglycerol? So remember triglycerides, for some of you probably, right? Whenever you have high cholesterol, your triglycerides are also high, right? So triacylglycerol are 3 fatty acids connected by ester bonds. Okay, so let's look at see if we can find triacylglycerol here, probably nothing here. Oh. This is actually a good thing. Maybe for some of you in your group, for anyone in the groups, if you cover prostaglandins, right? So, non-steroidal, what does this mean? NSAIDs, non-steroidal anti-inflammatory, you said that? Okay, Chris? Anti-inflammatory drugs, right? And so, it's based on inhibiting the enzymes that convert arachidonic into prostaglandin. And so, pain, fever, inflammation, when arachidonic, so the non-steroidal, so these drugs will inhibit the pain, right? So there's a very, very big market for that. So some examples are ASA, aspirin, acetylsalicylic acid, ibuprofen, and Aleve, right? So that naproxen. So we know that omega-3 fatty acids are also good for us. Which is better, omega-3 or omega-6?
Omega-3.
So, DHA. How many of you have tried supplementing or using that as a nutrient? You find it helps, right? I know. If I really want to study, like 17 hours, and not have my brain fatigued or fried, DHA really helps. Cool. So, for the exam, probably like stearic acid is and oleic acid. For you to remember, stearic acid saturated and oleic acid unsaturated. Okay? And then, so I need to look up what triacylglycerol is. So triacylglycerols are esters of glycerol. So what's an ester? So the ester has the formula OR, right? So make sure you know the difference between an ester and an ether. What's an ether? It's just R, O, R. Okay? So make sure you know the difference between the two. So triacylglycerols are formed when the OH, right, of glycerol reacts with the, so carboxyl, what's a carboxyl? Carboxyl, so if this is carboxylic, this is a carboxyl. Okay? So you'll note that when you read problems, that's why I try to use the bigger questions, so you get familiarize yourselves with test-like questions. Hydroxyl group of glycerol reacts with the carboxyl groups of fatty acids. So there's the, so fatty acids will have COOH, right? So remember the stearic acid, 18 CH2s, CH3, then 16 CH2s, then COOH, right? So it will react with the carboxyl of the carboxylic acid and the OH of glycerol. So glycerol has two OHs. So here is triacylglycerol. So there's the ester bond formed, C double bond OO. Pretty cool, huh? So here's glycerol, and there's the fatty acid, right? Fatty acid. So hence it's called triacylglycerol. And so the reaction then, you just remove, so any ester reaction is the removal of water, dehydration. So you remove this to form that bond. So can you see that? So here's glycerol, right? Here's glycerol. Glycerol, right? So it has the OH. OH. So what do? When we form an ester, we remove H2O, right? So we get our O, C double bond O. How cool is that, right? So that's essentially what the reaction is. So you gotta remember, think, right? Ester formation is always an alcohol with a hydroxyl with a carboxyl. Hydroxyl and carboxyl. So we learned it in chapter 10, right? How esters are formed, but then we turn it up a notch when we go to lipids. Now instead of not just one, but then three. Right? Then when we go to proteins, yeah. And can you imagine, like our DNA doing all sorts of reactions? And that's why it's quite hard to really understand all the diseases because it goes through so many pathways. Okay? So this is just some little nuances. That's why chemistry is really the background, the central science when you study biology. But then to know chemistry, you have a good understanding of a little physics and math, right? Because that's the baseline for chemistry also. And so at this level, I don't expect you to memorize all the different types of fatty acids, right? Know that oleic acid is good for me, stearic acid, maybe occasionally. So with a 16, right? So with 18 carbons, stearic acid, oleic acid, also, but then there's a double bond in between, and then a few other types. So a fat is usually solid at room temperature. And so meats, whole milk, butter, and cheese. So for those people that were raised in the farm, well, they made their own butter too, right? And so an oil is usually liquid at room temperature. And we have olive oil or sunflower, or corn oil, canola oil, and all sorts of oils. Even grape seed oil. So that's a nice picture of space filling model of oleic acid. Okay, and then we want to look at steroids and cholesterol. So when we see a structure like this, right, where you have 1, 2, 3, 4, this is referred to as the steroid nucleus. You have, these are 3 hexagons, right? And then a pentagon, so 3 cyclohexane rings with a cyclopentane ring. And the numbering, so cholesterol is the most abundant steroid in the body, has a methyl group. So there's methyl, methyl, methyl. But once you see something like this, so that's the steroid nucleus. So we can get it from meats, milk, and eggs. Our body also makes it. Oh, sorry. Look at this. And so here's a normal artery, and look at a clogged artery. Yeah. So there are all sorts of non-invasive ways to unclog those arteries these days. So you see that cholesterol plaques, right? And that's why, you know how some Italians, I think, they take olive oil, right? They drink olive oil or a tablespoon of olive oil or something, so that the artery is nice and smooth, doesn't have any buildup of plaques in it too. So cholesterol is synthesized in the body, and it's very, very, very important. So actually, if you don't eat any fats or stuff, guess what? What makes it? Your body still makes it, right? And some actually really say one of the best sources of cholesterol, healthy cholesterol, is the egg yolk. So having eggs over easy, not scrambled or hard boiled. Because what happens, we'll see later, right, when we go to chapter 16. When you make a hard-boiled egg, you denature the protein, so it's no good anymore. The cholesterol becomes lousy cholesterol as opposed to the healthy cholesterol. I used to have a grandma that would drink a fresh egg every morning.
Yes.
People do that, yes. And so, with me, when I first came to this country, right, I ballooned in, I gained like 40 pounds in 1 month, because I used to order, okay, I'll have some chicken, I'll have some meat, hamburger, and I'll have some shrimp, right? I didn't realize you should order just one entree. So to make myself lose weight, I just had eggs and grapefruit for like 6 months. I got rid of the eggs, yeah. So that's why I thought this, this was looking at the different types of diet and nutrition and how to prevent certain diseases, right? But still these days when I eat, it's still nice to have hamburgers and French fries, right? So I always would take milk thistle to defat the liver.
Yeah, after that, diet coke.
Yeah, right. To clean up the liver because it's getting a lot of work. So elevated cholesterol could be anything over 200 milligrams per deciliter, right? So if you don't eat fatty foods, guess what? Your liver will make cholesterol. So might as well digest or eat healthy cholesterol. So here's some cholesterol contents, right? A large egg, milk. And I used to eat lots of beef liver before, right? In the 60s and 70s. But because of the mad cow disease, right? Now we don't sell it. Hardly sell it. Unless you know that it comes from kosher farm. And that's why eggs are still the cheapest, right? Very balanced. Yeah, I could eat 4, 5, 6 eggs.
Is there a difference in the cholesterol level whether you look at is large or small?
Yeah, there might be slight differences, yeah. Because, yeah, there are some large, jumbo eggs, right? But that's the one that's not probably farm raised, right?
Yeah, that's true.
Because then it's been fed hormones to get the eggs
It's
bigger.
not too healthy.
Yeah. So that's why Martha Stewart has her own egg, a chicken farm. So look at, this is another good test for your recognizing the different types of functional groups again, right? What's the steroid nucleus? You see it, right? Steroid nucleus. What is the A is the hydroxyl group. What is B? Double chain. Where's the methyl group? CH3, CH3, right? All the CH3s are methyl, right? Because CH4, methane. So when you remove one carbon, so then now it's a functional group, and now it's methyl. Okay? You see how they go about
One carbon or one hydrogen?
one carbon, methyl, right? So ethyl would be 2 carbons. See? So this is ethane, right? Ethane, right? So I remove hydrogen. So that's called ethyl. Ethyl.
So remove a hydrogen, right?
Yeah, remove the hydrogen.
Except carbon.
Okay? Yeah. So 1 carbon, methyl, 2 carbons. So this is very important in your exam. I think if I recall, there's a question that has to do with this functional group. What do you call that functional group?
Okay.
So you will want above all the propel. Very good. Someone's ready to take the exam. Anthony. You ready, huh? Okay, look at bile salts. Have you ever seen bile salts? Synthesized in the liver from cholesterol and stored in the gallbladder. Bile is important for us. But gallstones form in the gallbladder when cholesterol levels are high. So we knew someone that said that having those gallstones removed will really give you a lot of pain. I know they zap them with lasers now, right? Also. But then someone said, even that still hurts. So, wow. So bile salts. A bile salt is, an example here is, you see how the the bile, right? And then Na plus, right? So sodium, glycopolate. So from glycine and amino acid. So we'll look at amino acids later in chapter 16, but the lipoproteins, so lipids are also involved in the transport of lipids that are bound to some proteins or lipoprotein. Lipids are therefore non-polar, and then it becomes more soluble when they're combined with water-soluble proteins, because the glycerol phospholipid, and so we call them lipoproteins. And so here is an example of our cell membrane, right? And here are the hydroxyl groups. And then the round green are the polar. These are polar groups, and then the wiggly lines are the alkyl groups, non-polar. So lipoproteins could be the low density, or I call them the lousy ones, right? And then the high density would be the healthy. And so plasma lipoproteins has all of these different types of lipoproteins: triacylglycerol, phospholipids, cholesterol esters. So you don't need to know these transports also. You'll note from we started out 3 fatty acids connected to glycerol by ester bonds, right? What is a triacylglycerol? They are fatty acids connected to glycerol. So if we hydrogenate, right, of unsaturated fatty acid, what do we get? We get trans fatty acids. What groups can replace a fatty acid in a glycerol phospholipid? Yeah, you probably won't get this because I didn't discuss. You'll note that if I didn't discuss it, you won't have it in the exam. Because this is more the chapter 14, and I didn't really cover chapter 14 because we're only 12 weeks instead of 16 weeks. But what characterizes a steroid? Steroid is quite important, right? So a steroid has the 4 fused rings. It's not an amino group. It's not 3. There were 3 cyclohexanes with 1 cyclopentane, so 4 fused rings. It's not long carbon chains, right? So steroids very, very important. And then we need to recognize what's the hydrophobic end of the glycerol phospholipids in the cell. The hydrophobic, so remember the cell? So you had the hydrophobic ends are the ones inside. Hydrophobic are here. Hydro, that means non-water loving, right? Hate water, like hydro, right? So hydrophobic, right? So philic, the polar groups over here, hydrophilic, loving, right? Love water, so they're the ones that are the green ones, right? The cell membrane, remember? But remember, hydrophobic, hydrophilic. So so what is propyl? Hydrophilic, hydrophobic? I know you're mixed, right? Because it's kind of in between, but if I made this more probably phobic, right? Because these are where the alkyl chains are, right? So it should be hydrophobic. Well, these are hydrophilic, right? Hydrophilic, hydrophilic. Whenever there's O, if they can hydrogen bond, they're hydrophilic. So very important, attractive forces of hydrogen bonding, right? So what others can hydrogen bond other than oxygen? Nitrogen, right? Also. Any questions? Yeah? Okay. So, facing each other inside the cell wall, right? So facing each other, right? Inside. Of the following functions of lipids in the body, what is not? We know that lipids give us energy, right? Fats. We learned in chapter 2 that lipids provide how many? 9, right? 9 kilograms per mole, whereas carbohydrates and protein only 4. So we get more energy from lipids and fats. They tend to protect our organs. They are also insulation, right? Fats insulation. But no, they do not destroy membrane. They're like the padding. So all of the functions of, remember prostaglandins? I didn't emphasize it so much, but there are, what are the prostaglandins? Like Chris said, anti-inflammatory, right? Because they prevent inflammation. And if we can prevent inflammation, we can minimize pain, right? And that seems to be the name of the game, right? All the painkillers that people are taking. And so, I won't ask you what fatty acid is not essential. The answer is oleic. What is not an omega-3? I won't ask you that. This will not be asked, but this is interesting. A major form of energy storage for animals like bears that hibernate, triacylglycerol. So, logically, it kind of makes sense in that way. Which lipid in plasma has the most bad cholesterol esters? They're the lousy LDLs. And then, oh, this is really cool. Estradiol differs from testosterone by the presence of what functional group? Can you recognize what does testosterone end up with? Testosterone, ONE, right? Whereas estradiol is an OL. So if you look at the two structures actually, testosterone has a ketone, so it's testosterone, ketone, whereas estradiol is an OH. And that's pretty much the difference between the two, but yet they act quite differently. And we all need different proportions of that, right? Okay, so on to Chapter 16, proteins. So what's a protein? Proteus, first, most of what we need to survive are made up of proteins, right? What's the definition of protein in our textbook? So proteins are made up of amino acids, right? So if we have an amino acid that has a COOH, carboxylic acid side chain, what would be the charge of that side chain? So carboxylic, right? What does the carboxylic tend to do? The carboxylic will tend to have COO minus, because carboxylate. COO minus, so letter B. A polypeptide, okay, so it's classified as a protein, so let's take a quick look at our chapter 16 polypeptides real quick. And you saw the type of questions that you will see next week, right, from the worksheet? I know you have yours handy with you, Anthony.
Yes.
Can I borrow it for a minute? So you'll note that it's pretty heavy on functional groups. Okay. Sorry. So for proteins, you will note that the proteins are made up of several types of. So for proteins, structure determines function. So you have collagen that gives support. You have myosin and actin that contracts, so for muscles. You have hemoglobin that transports oxygen. You have casein that stores protein in milk, or ferritin that stores iron in the spleen and liver. And there's insulin that regulates our glucose. And then, of course, all sorts of enzymes. We ran across amylase. There's sucrase that will break down sucrose, right? So sucrose. So you will note that what's quite important, the building blocks of proteins are referred to as